Assalamu alaikum warahmatullahi ta'ala wa barakatuh. Ladies and gentlemen, welcome back to another video. So let's get started. First of all, let's have a look into my latest commit, which I fixed some things that I've done in the last tutorial. Okay. So first of all, I want to go directly into the real thing, which is here, call mode. So I kind of misunderstood it at first. So you're not supposed to tell it which side of the triangle to show or to render, but to actually hide. It's like the opposite. So instead of saying to it, hide the front face, I should tell it to hide the back face. Okay, that's what I was intending, at least. Although that one would have worked in any ways, but it is not what I intended initially. So I just removed that call mode Viki, call mode front bit, and I replaced it with back bit. Second thing is that polygon mode Viki, polygon mode fill. This is not a bug, but this is just something that is not needed. Polygon mode fill is equal to 0, so you can just get rid of that altogether. There is no need to specify it. The other thing in the swap chain, I actually forgot to set the image extent property, because we're gonna need it in the future, and I forgot to set it because as you can see here, I didn't have this line, and I was saying .image extent equal capabilities .current extent. Now I actually set it to the swap chain, alright, as you can see, and then I set it here. Alright, lovely. That's about it for the swap chain. And also I forgot to set the pointer to scissors. There you go. That's another one. The other change that I wanted to do is to remove the dynamic state altogether. We're not gonna care about changing viewports, etc. right now. We're not, and the scissors, so we don't even need dynamic state right now currently. When we're gonna need it, we can actually again try it out, but for now it's fine. I also forgot about max depth in viewports. Now, minimum depth and max depth needs a tutorial by their own for the viewports, but for now, just set it as max depth is equal to 1.0f, okay? Just forgot that property. There you go. As you can see, I also removed the array of dynamic states that we had before. And of course, since I actually changed the, by the way, since the tutorial is using clockwise order, right? Not anti-clockwise, which we're using, well, we gotta actually do some change on the shaders. I mean, look at that. The shader code have changed, as you can see. And here's the real change. I basically made sure to actually switch the order, right? So the first vertex becomes the last one. The middle, of course, will stay the same. And then the first vertex will become the last, and the last will become first, basically. And of course, I just compiled the shader again, just like I did before, and copied the code, the byte code of that shader into, just like we did before, just like we compiled it in the previous tutorial. And that's basically it. For the fragment code, it didn't change. There is nothing to change there. We just had to change the order of the positions. Even the colors, you don't need to change it, right? Because the colors really, I want the first vertex to be red, whatever the first vertex location is, right? So that's basically it. Now let's go back, and we're gonna start today with the Renderpass. So what is a Renderpass in short? Well, again, I really recommend looking through the tutorial. I'm not going to go into a lot of details, but let's go where we need to go now. Okay, here, as you can see, this is our code. Pretty cool stuff. Scissors, image extent, viewports. Pretty cool. By the way, I did research about the layout, the pipeline layout in the server, in the graphics server, which you can join in. You can find the link below. You You can ask your questions there about Vulkan. But basically, I found out that you can actually destroy the pipeline layout after the graphics pipeline is made, as long as, of course, you're not going to be using that pipeline, that pipeline layout later on. Since currently we're embedding those vertices into the shader directly with no layout or whatever, we don't really need it, after the graphics pipeline is created. So what we can do, this is not needed, but what we can do in this kind of configuration, in this kind of use case, we can just destroy also after creating our pipeline, since we only need it here. Okay. But yeah, later on we're gonna need it for sure, so we're gonna destroy it here until the pipeline is destroyed. But yeah. Oh, what I did here, not destroy pipeline, I want to destroy the layout. Okay. And there you go. So you can destroy the pipeline, the shader modules, and there you go, after creating the graphics pipeline. Alright, so that's basically it for that one. Now let's see what about the render pass. For sure, first of all, I'm gonna actually make this into its own function called graphics pipeline create or pipeline create. So void graphics pipeline create, it's gonna take in the state just like that. That's graphics pipeline create. Now let's copy this whole thing, and there we go. And here I'm just gonna say graphics pipeline create state. We could still refactor more, but right now let's not focus on that. Okay, and there you go. So that's basically it for that one. You could also go ahead and say void graphics pipeline destroy state. There you go. And only thing that we have there is this guy. So you can say graphics pipeline destroy, give it the state, and there you go. Lovely. Next up is, now let's actually try to create the render pass. And where are we going to create the render pass? Well, before even creating graphics pipeline. So render pass create state. I'd like to think about the render pass is like the blueprint of the rendering operation, like for the graphics operations. Like, I don't know how to say, but basically describes the steps that's gonna happen. What are the compatible shaders? What are the compatible layouts? What are the compatible pipelines? It's kind of like, I like to think about it like a blueprint, but we'll see. So here, render pass create for the rendering operation. So render pass create. Let's create a new function. So void render pass create state. There we go. Okay, vk create render pass. Here we're gonna give it the config context.device. Here we're gonna give it a pcreate info. So render pass create info. Next step is the allocator. And then where to put it? Well, I'm gonna put it inside the renderer. And now I'm gonna create render.renderpass. Now let's create that field inside of the renderer, and there you go. We have it now. Lovely. All right, next up is what it is. Well, I still didn't actually put the info there. Alright, so let's actually configure now the render pass. Alright, so dot, of course, s type. So render pass create info. There you go. Why it did that raise thing? Anyways, dot next step is subpass. We're only going to be using one subpass, and this is usually the case for most usages, right? So one subpass, we're going to set subpasses to something. In this case, I'm just going to create an array for it, right? And we're going to need another guy, which is the attachments. Attachment count, we're going to go with 1 for now. Or in fact, we can do that trick that I've shown you before, which is size of. So size of subpasses in bytes divided by the size of each element of that subpass. Right, so we can get the count. Right, that's basically it for that one. Next step is the attachment count. Same thing here. Size of subpasses, but this time it's size of attachments. Although the type of these guys are vacay attachment description, so let's actually call them description. Vacay attachment description, vacay subpass description, because there's also other types of attachment stuff which we'd like to, differ between them. All right, so I'm gonna say, instead of attachments, I'm gonna say attachment descriptions. Attachments description. Or attachment descriptions. Let's go attachment descriptions. All right, fine. Same thing here. And let's make sure to give it the attachment. P attachments is equal to that guy. And there we go. And now I don't care about dependencies for now, because I only have one subpass. Although, yeah, actually, I may care about it later on, but for now, let's just keep it like that. Now let's actually care about the subpasses. First of all, let's start with the subpass, I think. Yeah, fine. So vacay subpass. All right, so vacay subpass. Oh, there are also descriptions. Okay, so we can say subpass descriptions. Descriptions. There you go. Oh, subpass like this. And here we can say subpass descriptions. Nice. And this is of course an array. And that array will only contain for now one subpass, right? And it will only have one color attachment. Color attachment is basically an attachment that we can draw colors into. Because there is various types of attachments. For example, there is input attachments, which can go into the input of shaders. There is, while color attachment is output in most cases. So there's also depth, there is all this sort of stuff. For example, resolve attachments, you would use them for multi-sampling. And there's all sorts of stuff. Anyways, I only care about one color attachment, and now let's give it those color attachments, which are vacay attachment references. Okay, so here I'm gonna say color attachment references. Okay, so let's create that variable. All right, so vacay attachment reference. Color attachment references array is equal to this guy. Only gonna have one attachment reference. The attachment will be index of 0, and the layout will be the swap chain layout. So let's grab the layout of the Renderpass actually. Okay, so not let Rust. Okay, layout, vacay layout, right? Vacay image layout. So image layout, or should I say color attachment layout? is equal to what? Is equal to state swap chain, well, window first, dot swap chain dot image format, or format, okay. Dot format, and what's going on here? Oh yeah, it's vk format actually. Yo. What? Hold on a sec. No. What I'm doing here? That's not what I meant. Okay, hold on. Oh, it's not layout, but I do need the image. I kind of was thinking about something else. Layout is equal to what? So vk layout color attachment optimal. This is basically what you want to use the layout for. In this case, I want to use it as an output, as kind of like a render target for colors. So I'm going with this layout color attachment optimal. Alright, kind of drifted away there, but yeah, expected at the end of the declaration. Alright, sure. Let's make sure to add semicolons around there. And there we go, we have one color attachment reference and one subpass description. Next up is the attachment descriptions. So vk attachment description, attachment descriptions, array, incompatible pointer type initializing, cast expression please, thank you. Alright, we basically just casted explicitly the array into a pointer, basically, so yeah. Next up is vk attachment description. Vk attachment description. Let's see. So let's make one attachment description, and here, there we go. Here's the format that I was talking about. Okay, now let's go back and do it. Vk image format, or actually vk format. Image format is equal to. Alright, state swap chain, a window, swap chain, a format. There we go. We got the image format. Now we can set it. There we go. What's next? Yeah, we do have a lot of beautiful stuff in this one. Okay, let's start by the samples. Let's get away from here. Since we're not using any MSSA stuff, just set it to 1 bit. One sample basically. Next up is the sadly it's not equal to 0, so we can't really get rid of it, which I would have expected is the default, but yeah, what you gotta do about it. Next up is what Lloyd, there's store and okay, let's start by actually initial layout and final layout. So the initial layout, since we're just starting our render operation, this is the first subpass, we don't really know what could be the layout, so we can like it's indefined, so we're gonna say image layout indefined. That's the initial layout. The final layout that we want to take is the actual present src khr. src stands for source. So basically we're telling the subpass to actually convert or transition the image layout into vk image layout presents src khr, which should be the layout if you want to actually present an image into the screen, an attachment to the screen, which is in this case we do want to, so that's why I'm saying vk image layout present source khr. Okay. Next up is store op, which is also interesting. Okay, store op. So for store, yes, I do want to store the final results of the rendering, so I'm gonna say vk attachment store op store. All right, next up is the not actually, this is not, should not be stencil. Let's see, hold on a second. It should be store op, not stencil. I don't care about stencil. Okay, also I need Lloyd op. which is going to be equal to Lloyd OP, make attachment. So for the first, when I just loaded the image, I want to actually clear it with some color. Okay, that's why I'm gonna say at Lloyd OP, the Lloyd operation will be clearing the image at first, and second, the output of this rendering operations, we're gonna store it. We're not gonna keep it. We're gonna preserve that data. Okay, store OP like this. There we go. For stencil, I don't care about it, so I'm gonna exactly say that, so don't care. There you go. And stencil Lloyd is equal to don't care. There we go. Let me, just for convention, I'm gonna add the Lloyd first because it makes sense chronologically. Okay, so that's basically it for that one. I think, did I miss something? Final layout, flags. I don't think there's any interesting flags that we could look into currently. Let's see, no, nothing interesting for now. Okay, so this is basically it for our attachment description. We only have one attachment. And by the way, I still didn't actually explain why I put it 0 there. Because basically in my vertex shader, not vertex shader, fragment shader, what I'm expecting, I'm trying to output into some kind of image, right? Into some attachment, right? We have this out here, output. And what is the location? It's 0. So the first attachment index of 0. That's why here I'm actually making an attachment and the index 0 and binding it into 0, okay? In some sense, color attachment optimal. All right, lovely stuff. Color attachment count, pretty cool. Did I miss anything here, by the way? Yeah, I did miss a lot. Okay, I'm glad I checked. All right, so pipeline bind point is the first one. I'm gonna go with graphics pipeline bind point, and the other one is because basically you just tell it which pipeline you want to use it with. Do you want to use it with a graphics pipeline or a compute pipeline, or what exactly you want to bind this render pass to, or this subpass to be exact? Okay, because I think you may have multiple subpasses that could be for different stages, like for different types of pipelines, if I remember well. Anyways, so let's see some other thing. Color attachments, we have done that. Yeah, so I only need that guy. I don't think flags are interesting again, at least as a beginner, right? So for now, yeah, nothing crazy there. Okay, fine. So that's basically it for our subpass descriptions. Attachment reference, lovely. And of course, we're gonna make sure to actually add our expect. Let's add a meaningful error code or error message. Couldn't create a render pass. As simple as that. And there you go. Awesome. Now let me make sure I'm actually adding that render pass here. And the render pass is equal to what? To state render dot graphics, not graphics, no, render pass, right? There you go. So here I'm passing my render pass into the graphics pipeline creation info, okay? And I'd like to do one little thing just for organizational purposes. I want to group the, like, put the layout and the stuff that depends on the vertex layout in their own place, like in the start, because that's really the first stage. So the layout, and there's also the vertex input state and the input assembly state. These three are kind of related to each other, right? And just for organizational purposes, I'm putting them together. So yeah, stage count, stages, viewport state, rasterization state, multi-samples. By the way, when you set the dynamic states, like for example, if you set the dynamic state of viewport and scissors, you don't have to actually specify the state. In fact, it's going to be ignored, right? Because it is always going to be like expecting you to actually give it the viewport at when you run the the graphics pipeline. Okay, that's the thing. So if you're setting that dynamic stuff that we've done before, you can actually go ahead and remove this, and you have to because it's gonna be ignored. Okay, it's gonna be ignored. So yeah, I think that's pretty much it for the render pass, and hopefully now we can actually create a good graphics pipeline without any problems. Hopefully there is a validation error. Yes, it's about destroying because I didn't destroy the render pass, I think. So render pass destroys. So when to destroy the render pass? Of course, again, kind of like the stack thing. First thing that gets created is the last thing that gets destroyed. So render pass destroy state. Okay. So now void render pass destroy. There we go. State. Now I'm just gonna make sure to vacate destroy render pass. Here I'm gonna give it the context.device. Next up is the render pass, so render.render pass. Next up is the allocator, so state config.allocator. And there we go. Awesome. Now if we run this, we should have no problem at all. There you go. As you can see, now we have successfully created our render pass and our graphics pipeline. Okay, and now next step is the frame buffers, because right now we have actually created the descriptions of our attachments, but we need to bind those descriptions to some images, some image views to be exact. Okay, and those image views will come from the swap chain. Okay, so basically those slots, for example, the slot that we have for color, attachment, it's index of 0. We gotta attach an image view, an actual image view into it. Okay, so yeah, it's kind of like right now we created the USB ports of the computer. Now we're gonna actually bind something into those USB ports. So you can, that's how I like to think about it. So yeah, now let's see. So after render pass, after graphics pipeline, we can create our frame. Now here we have two things. So we can either create the frame buffers in the swap chain, or we can create them in the render. Okay, but we don't care. I'm just gonna create them in the render because they depend on the rendering stuff. So anyways, frame buffers create. Okay, here of course I'm gonna give the state, and of course let's not forget the render destroy. Okay, let's actually destroy the frame buffers. So frame buffers destroy add state, and now let's create those two functions. Void frame buffers create state. Okay, so first of all, we gotta allocate some memory for the array of frame buffers that we're gonna create. And before that, let me first of all grab some stuff from the swap chain, some information from the swap chain. But you know what, let's start by trying to see what we need to create a swap chain. Not swap chain, frame buffer. Okay, here you need of course again the device. By the way, a fun fact is that the logical device, the device can actually abstract away over more than one physical device. So you could have, for example, 2 GPUs but one logical device over both of them, which is quite an interesting fact that I learned before. So yeah, that's just something to know. Create info. Next up is the allocator as always. Config allocator. And of course, you're gonna give it where to put those frame buffer, where to put that frame buffer. So we're gonna say state, address of. I'm gonna give it where to put it. So that's why I'm gonna use address. So state frame buffers. I'm gonna tell it where, which index, because that's gonna be an array in a second. So I'm gonna give it index of frame buffer index. Well, as simple as that, frame buffer index. But of course we don't have frame buffer index, right? And by the way, I need the error message. Couldn't create frame buffer. And we could also go fancy and tell exactly which frame buffer we're talking about, which frame buffer index. So here we go, our macro is working out, lovely. Next up is, well, we need that frame buffer index. How are we gonna get that? Well, of course we're gonna create a for loop. And that from for loop frame buffer index, there you go. Less than, well, here I'm gonna get the frame buffer count, okay? Let's go, frame buffer count, there you go. Now what is the frame buffer count? Size, or let's just go with UN32, I think. Let's just go size T. You know what, since Vulkan is using always like U32, let's just do that. UN32T, frame buffer count, I think, is equal to swap chain window. Always forget swap chain dot image count. There you go. What's going on here? What's the problem? Okay, awesome stuff. Now we have the frame buffer count. As you can see, we used it here. Awesome. Now let's actually grab this thing and put it inside that loop. Okay, so basically for each image in the swap chain, we're going to create a frame buffer. And of course, we don't know what is a frame buffer, so there is not that thing there. So let's actually create that field. It looks like my IDE failed to identify the type, so let's actually give it the type vk. It's going to be a vk frame buffer. I'm going to put a pointer because I want to put an array there instead of just one object. Okay, so now we have that pointer, but it's not pointing to anything, it's just pointing to garbage, right? So we gotta actually allocate memory and point it to it, okay? So how to do that? Well, we're gonna say state config.frame buffers. Well, not config, render.frame. Yo, where did I create that thing? Hold on a second. No, not the state. Oh my god. I want to create it in the renderer. Let's actually, first of all, before I forget, let's remove it from the state. I'm just gonna paste it into the renderer. There we go. Okay. Awesome, awesome, awesome. Now we have our stuff ready, which is awesome. Okay, so that's basically it for that one, I think. Okay, so state render dot frame buffers equal to what? Is equal to malloc. Okay, malloc what? How much bytes? We're gonna malloc frame buffer count times size of in bytes of the vk frame buffer. There you go. Next up is we're gonna make sure that the allocation have succeeded. So we're gonna say expect that state render frame buffers is what? Is equal to null. So if that's the case, then we're gonna error. And what's the error is, well, couldn't allocate memory for frame buffers array. There you go. That's pretty much it, hopefully. For destroying frame buffers, and remember, whenever you use vacate create, you have to use vacate destroy. That's just how it works. So void frame buffers destroy state. So next up, we're gonna actually say free. Well, before free, we're gonna first of all loop through all the frame buffers. We're gonna make sure to destroy them first. So I'm just gonna copy this loop right here. And there we go. I need the frame buffer count, of course. There we go. So now it's a matter of destroying. So vacate destroy frame buffer. Oh, context of the device. Okay, next up is the state. Context.frame, not context render. Frame buffers, frame buffer index. There you go. And the allocator. There we go. And this guy returns void, so it doesn't really return results, so we don't need to expect in this case. And so now after destroying all the frame buffers in the array, now we can destroy the actual array, deallocate, free the array memory. So, and of course you should make sure to do this because otherwise you're gonna have a memory leak. So just make sure whenever you use malloc, use free. Whenever you use vacate create, use vacate destroy. As simple as that. Although what's not simple is that we tend to forget as a human being. So yeah, just trying to make it a rule for you. Whenever you use malloc, use free, definitely, like immediately, if possible. So state. Now state render. Okay, render dot frame buffers. So basically, you're gonna deallocate that memory or free that memory. All right, awesome stuff. So I think hopefully that's pretty much it. Oh, actually, we still didn't, specify the properties of the frame buffers or the information of the frame buffer. So .s type, of course, frame buffer create info. There you go. Layers, I only have one layer in my images, in my swap chain images, so only one. Renderpass is renderpass, as simple as that. Next up is the height and the width, the attachment count. Okay, so the width and the height. So width is equal to, of course, frame buffer width, which I'm gonna grab from the swap chain. And the height is frame buffer height. I'm also gonna grab from the swap chain. And next up is the attachment count and the attachments. Okay, so for the attachment count is going to be equal to size of, while, but by the way, hold on a second, it is a vacate image view, as you can see. Oh, it's, yeah, I see. So vacate, here you give it an array of image views of the attachments that you want to bind, and of course it should be like, for example, if you have 3 attachment descriptions in the render pass that you used in the frame buffer, you also of course have to make sure that you give it the same count of the render pass. And in fact, we could even maybe like store some abstraction later on the render pass, right? Tell the render pass how much attachments it has, etc. But anyways, so for now, let's just say size of vacate image view. Not image view, no. Okay, so image frame buffer image views. So image views. Oh, I forgot, by the way, that I'm using another kind of naming convention. Yeah, I forgot. Let's actually rename this stuff. I'm using the other naming convention, which is this guy. Same thing here. Glad I noticed right now. Just using refactor. Okay, image views. And of course, this refactor actually changes it everywhere here, at least in this function, but yeah. Could create frame buffer index. Now nice, alright, nice. So image views divided by size of dereference image views array. And the array will be stack based. So we're gonna create for each frame buffer, it's gonna have its own array, because each buffer will actually bind to a different swap chain image, basically. So here we're gonna actually say vk image view. Image views is equal to what? Well, it's an array. And we gotta here reference the image views that we want. Now, to be honest, since I have only one image view, let's just reference the frame buffer image directly, like the swap chain image directly. Okay, for now. There we go. Attachment count dot, because it's gonna be like an array of references, which is gonna get tricky if I want to use an array. Maybe even impossible. I don't know exactly, but we'll see later on. For now, I don't care. Just attachment count 1. I'm gonna hard code it for now. P attachments is state. Not state. I'm gonna reference the vk image view. Okay, here, image view, or color attachment image view. Okay, so what's this? This is of course vk image. Or you know what, let's just do it directly anyway, fine. State. Swap chain, image views, and here we're gonna index what? And notice I didn't pass the image view, but I passed the index of image view. Frame buffer index, not count, but index. There we go. Okay, nice. Declared here. What is it talking about? Frame buffer width. Oh yeah, I forgot about frame buffer width. Create new local variable. Oh, it's a uint32t, bro. Frame buffer width will be the swap chain. So state window swap chain dot image extent dot width, and there you go. So we could actually just say frame buffer extent, right? Frame buffer extent, and just grab that guy. Now we could just because, well, the frame buffer extent will be the same on all the frame buffers, right, of these swap chains. So frame buffer event extent initializing with an expression. Oh yeah, vk extent 2d. Now what I can say is frame buffer extent dot width. Frame buffer extent dot height, and there you go. There you go. Actually, let's try to do this with an array then. Fine, let's try to do that. So vk image views. Attachments image views, which is an array. It's going to be equal to what? Now only going to have one thing, which is that guy. Yeah, that's the problem, because that is a reference to an image view. Yep, so we cannot do it for now anyways, because I don't want to allocate memory right now and stuff like that. Fine, we only have one, so no need. So that's pretty much it, I think. Now, of course, we malloc. Yeah, free, there you go. Destroy, of course, create. Alright, seems all good. Seems all good, unless if I missed something. Layers, attachments. Is there any interesting flags? See, there's imageless. That's pretty much it. Okay, fine. Nothing interesting for now. Now, hopefully, of course, I have my expect there. Lovely. Now, if I run this, I have no errors, which is a good sign that it worked. So that is amazing. I can show you something cool before I think we end this video for now. Next up, it will be about the command buffers and all that crazy stuff. And I think probably the last video will be the next one, or if I made it shorter, and it's gonna be the next of the next, right? But surely we're not too far away from the triangle that were promised. All right, so yeah, that was it, I think, for this video. Hopefully, make sure, by the way, please to join the Discord right there. I post notifications about videos. I post if there is some fixes that should be done or something like that. But yeah, anyways, for now, what I would like to do again, I forgot what I'd like to do. Anyways, fine, let's commit this, guys, I think. So this is what we changed in this video. We added the Renderpass and the Framebuffers, as you can see, to the headers. And the render, here's what we've done. Let me zoom out a bit here. Here's what I've done. I added the in create shader module. I changed something or what? What? No idea. Anyways, so we have Renderpass. Yep, pretty cool stuff. This is what we added. Renderpass destroy. And so yeah, I'm gonna end this video right here. Goodbye everyone. Thank you for watching. See you later. إلى اللقاء.